Let me tell you briefly about who we are. Alpha Biosystems is out of Wichita, Kansas. That is our manufacturing facility. All the products we'll talk about tonight is manufactured there in Wichita. About 3 or 4 years ago, we started Alpha Ag Solutions as a division of the company, primarily just to focus on agricultural aspects of the company. The Ag group is our largest group, and it stretches across anywhere from wastewater treatment to grasses to crops to commercial composting, kind of as a general rule where we fall. And let me just say briefly, what this won't be is a sales pitch. I'm from the technology side of things, and so what I'm going to do is just kind of walk you through this whole concept of soil health, soil management, and then how the products overlay into that process. Soil. When you think about soil, whether it's this picture here or anything else on, whether it's a ranch, a farm, any of our producers, soil is an asset. And since it is an asset, we need to manage it as an asset. And part of that is making sure that the soil is as healthy as possible to get the maximum benefit for whatever you're growing. And so I'm going to talk a little bit about this concept of soil plant biology, what that means. Then, excuse me, we will talk about just the biological technologies that we represent, the concept of microbials, mycorrhiza, and then we'll talk a little bit about some 2014 results and what we've been seeing. Soil health is nothing more than the capacity of that soil to function for its intended use. Pretty straightforward. If your soil health is declining or damaged, then it can't function in that capacity. And that's the whole concept around it. Your soil biology is there as the most critical aspect in that soil from a plant standpoint. You must have healthy soil biology if you're going to get maximum growth out of it. And soil should be one of them that we don't think about, but soil should manage that flow of energy from the sun. That's where we start photosynthesis. That's where it carries through any plant growth we're talking about. It must be able to store and release water. Storage of water is critical. Water is becoming the most critical parameter in whatever you're growing. And the reason being is we've all been through drought years. We know what the impact of a drought can be. And so how do we better manage that soil water, or soil solution as I will refer to it, so it gets to the plants? And then ultimately we got to cycle crop nutrients. And I'll throw out the word, just understand the word crop can be grasses, it can be row crops, it could be anything that's growing, it can be vegetable crops. We cover all of those, so I use the term crop interchangeably, whether we're talking grasses or anything you're trying to grow. So this whole concept about cycling crop nutrients, you have to understand that we talk about the most is what? Nitrogen. Because nitrogen is the one thing that we can probably visually see in any, whether it's a grass or not. The challenge is all of your nutrients in that soil operate in a cycle. And if those cycles aren't functioning the way they should, that's when we have challenges in growth. One of the things that happens in a drought, you drop soil solution. And when you drop soil solution, now you shut down the soil biology. Therefore, the plant's not getting the nutrients it needs to grow. We talked about this real quickly, but the thing about storing and releasing water is we want to maximize what we get. If it's running off or we have ponding in an area, generally it means the soil's tight. And that can be a challenge to grow anything in. Or commonly we see on the side hills. Side hills create challenges for two reasons. One is to hold the water, and two is to hold nutrients. They tend to run off. So when we look at what goes into a soil, this is kind of the common picture of, if you will, quote unquote, the perfect soil, about 45% mineral matter, and about 25 air, water. Air is important because we need an aeration zone for the roots to grow and for the soil biology to proliferate. Here's the king though, it's organic matter. Organic matter makes any soil go. It ties to your nutrients, your ability to store nutrients, it stores water. Most importantly, it ties directly to your soil biology. If you have poor organic matter, you are going to have poor soil biology, because this is much of the habitat of most of your soil biology. So when we start to look at our soil, how do we know if your soil is healthy, damaged, all of the above? Well, there's some simple ways to look. One is to dig in it. If you dig in that soil, you're going to determine what the soil health is by looking at the tilth. Do we have a real rich tilth? How deep is the soil? Is it a shallow soil? But more importantly, do we have shredded material, or in this case, do we have root residue that's breaking down? But more importantly to me, is there signs of life? Can you dig in your soil, and what's the number one thing you should find in all of our soils? Earthworms. But what we find is, earthworms are very sensitive to compaction, to certain chemicals, and we find once they migrate out, it starts to deteriorate from a biological standpoint. What about color? Color gives us some interesting insights. Drive through Oklahoma, what do you see? Red dirt. That's a high iron dirt. It doesn't mean the fertility's bad, but it already gives you an indication it's not where you want, because your darker color is where your higher organic matter is. A couple of other things is do we have mixing soil profiles, or are they very distinct layers? And a good way to look at that is on a highway, when you go through a crosscut, look back at the soil. It's going to tell you a lot right there how that soil performs. Here's my favorite, and every time I do this, people look at me like I just wandered in way out of the field. But if you smell that soil, it'll tell you a lot. One of the most important, if it's got an earthy, sweet smell, what it tells us immediately is you have Actinomyces bacteria, and we want those in our soil. They're a key indicator on your soil biology. Also tells us that we're cycling nutrients, and more importantly, this concept of a food web in your soil is really churning through. Now, if we get this, what we often refer to as metallic or kitchen sink smell, now we know that our soil is shifted to anaerobic, meaning it's not performing very well. And a good time to look at that, have you ever walked out on a flooded field after the water's receded? This is what you're going to smell, because everything's shut down when it's smothered with water. Or more importantly, if you have no soil aroma. If you have no soil aroma, you have a dead soil, not going to grow much. Sterile soil won't even grow the best of the weeds. And we got a good example of that here 2 or 3 years ago along the Missouri River. Some of those were the best farm ground around, and they were underwater some 90 days. When that water receded, nothing grew. And it killed all the trees, all the weeds, because once you suffocate your soil biology over that extended a period, it doesn't recover very easy. So let's talk about how we manage organic matter. We say it's a key in the soil management. It's absolutely tied to your soil health. How do we manage it? Well, you guys are doing a lot of it. If you're growing grasses, you're doing a lot of how to manage your organic matter to start with. Some of it is this prescribed grazing, high biomass rotations, anything. The most important thing to help an organic matter is keeping an active root structure, a good healthy active root structure. Then it will drive us to really higher productivity. Here's where I talk about, think of your ground as a bank account. And the amount of water and nutrient we store in them is tied to organic matter. 1% organic matter will hold about 10,000 gallons of water. Any of you know what 1 inch of rain will deliver per acre? 27,000 gallons per acre. So if we have 1% soil organic matter, we're only going to hold a third of that inch of rain. But if we can bump it up to 2 to 3%, now you can see 56 to 84,000. Or, stated different, now we're going to be able to hold 2 to 3 inches of rain. And this is also tied to storage of nitrogen. It's the perfect place to store nitrogen. And so when you think about it, the higher we can drive this organic matter, the more nitrogen we can store. So how do we build organic matter? We're talking about it. One way is bioaugmentation. Bioaugmentation is what we're talking about tonight, where we supplement the soil biology with the right soil biology, and through that process we'll start to stabilize first and then build organic matter. That's really the key here. Is the first step, if you've got low organic matter or deteriorating organic matter, you got to stabilize it first. Then you can reverse that. As we talk, cover crops, reduced tillage, crop rotation, forage crops, all those things which keep us, most of these will keep us an active root structure. So when we think about this, we talked about this soil food web that's in the soil. In that food web, there's multiple steps of organisms. Bacteria being one of the smallest, earthworms being one of the largest, and everything in between. If you take one of those steps out, you have damaged that soil, because now it's not churning like it should. And always remember, we think of soil typically as dirt, but soil is this vast, complex thing that's going on all the time. Your soil chemistry is driving one side in your soil biology. The way to help that soil be more efficient is to build biodiversity. And all biodiversity means is we have all of these organisms there, and there's a diversity of it. In bacteria, what happens is a lot of times as we manipulate soils in any matter, what happens is you create an area where mostly there's dominant species. Nothing wrong with dominant species, except when we get to that point, what we start to do is minimize biological efficiency. We're not pushing the same amount of nutrients, so what that plant needs, it's not getting. So diversity is really the first key. So bacteria. You all hear about bacteria all the time. What do you normally hear? Yeah, it's negative. But the reality is some 98% of all bacteria are what we have to have. For example, our skin is coated with bacteria. If we eliminate that bacteria, our skin would be diseased all the time. You ever think about it this way? If you've ever seen or know of a surgeon, look at his elbows. What do you see? There's usually eczema, a lot of scabbing going on. The reason is because they have to scrub down every time they do a surgery, and they're just eliminating the bacteria. And in many cases, even to the point of, I know this sounds odd, but some of these hand cleaners that are just alcohol and they tell you to rub them all over your hands, it's probably the worst thing you can do for your skin. Crop's perfect soil partner. That's what a bacteria is. And the reason is the crop, or in this case the grass, gives the bacteria what it wants, and the bacteria gives the grass what it needs. The nice thing is they're the perfect worker. All you got to do is feed them. They'll do their job, and they'll do it very efficiently as long as you feed them. No complaints, no strikes, unless you do something to damage it. Common ways to damage bacteria is over-fertilization, lack of aeration, most importantly is lack of organic matter. This is a microbe. Microbes primarily come in two shapes. This is what we call the elongated or cigar shape. The other one are perfect spheres. They're perfect circles. Thing about this, though, the reason I put it up here is we get asked all the time. Terra One is a product that's a soil amendment. It has to come in contact with the soil. The reason being is once these hit the soil, these string-like appendages move them through that fine spores. Remember, we're talking about something that you can only see with a 1000x microscope. This just happens to be an electron microscope picture. That's why it's so clear. Otherwise, you can't see them with the naked eye. Microbes hopefully are always present in your soil, and more importantly, they're hopefully in the diversity to do the tasks they're given. Interesting enough, you have the right microbes in place, they will suppress disease-causing microorganisms. They basically outcompete them. Same way if you take a probiotic, what are you doing? Or giving your animals probiotics, all you're doing is flushing the digestive tract with good bacteria. The bad can't get started. Same thing in soil. When a bacteria dies, remember a life cycle of a bacteria is really short compared to a human. Some of them only 8 to 24 hours, and that's their life cycle. When they die off, this is the elemental composition of a bacteria. You have carbon, oxygen, nitrogen, on and on. All the nutrients that your plants need. Now, am I telling you that bacteria can provide us enough nutrients? No. But they can sure help. But more importantly, when they die off, because they're such a high carbon base, they start to build humus in the soil. Humus is biomass, which in turn will help start to slowly rebuild organic matter. Types of organisms in your soil. I told you earlier, this is the smallest. This is probably the larger one in this group. But each one of these have a good one and have bad ones. No different than anything else. You have good bacteria, bad bacteria, you have good nematodes, you have destructive nematodes. In there, what we're trying to build is this biodiversity to give us the good ones and outcompete the bad ones. Bacterial services. These are some of the things that the bacteria will do in that. Nitrogen fixation, disease suppression, breakdown of hard to decompose compounds. And there's a lot of them in nature. But if you put the right species dependent, remember, with bacteria, at the species level, they do one thing, but they do it extremely well. So the key is being able to put a lot of them together. I'm sure all of you have seen, this is the nitrogen cycle. I throw it up because it's the easiest one to identify. You always start at organic nitrogen. Typically organic nitrogen would be that fixed nitrogen in like manures. It'd be urea, uric acid, any of those complex nitrogens. And then it breaks down as it comes around, and if you let it go long enough, it will return to atmospheric nitrogen. Wherever you see a red step in those cycles, it's driven by a specific group of bacteria. You eliminate this step, and suddenly now the whole nitrogen cycle will struggle in your soil. Remember earlier I told you all of your nutrients are in this type of cycle. Maybe not this complex, but it is an ongoing cycle, and that's the way nature delivers those nutrients. And it's all controlled by your soil bacteria. Benefits of growing living roots. We talk a lot about this regardless of where I'm at in the country because it's the fastest way to build organic matter back in our soil, is to maintain an active root structure. An active root structure is so important to your soil biology. Why? Remember what I said earlier. For the bacteria, they get their food from that active root structure. And in turn, the bacteria give back. So it's that continuous cycle. You stop that root structure, and some of those bacteria may or may not survive. And this is kind of what drought does to us too. It stops that. The other thing is what soil, where does bacteria fit into hot soils? Now I'll tell you, it sounds odd to talk about 100 degrees in soils, but I do a lot of soil temps. This is not uncommon in the middle of the summer, especially in Texas, Oklahoma, and Kansas. Kansas, I've seen them as high as 108 degrees on a hot summer day. So what we want to have in this is this ability to fluctuate through that so you don't damage that soil biology. Here's the most interesting one though. At 70 degrees, plants are going to utilize almost 100% of the moisture. But as you start up, this starts to change. Now at 113, certain species can die off. If you get up into this range, yeah, we're going to lose most of them. Mycorrhizal. How many of you have heard of mycorrhizal? Mycorrhizal is a beneficial fungus that should be in all of our soils. Trouble is we, over just normal practices of farming, we start to lose mycorrhizal. Mycorrhiza is this web-like structure you see over here. And mycorrhizal does a couple of things in that soil for us. One, it creates these bright white spots you see, and that's called glomalin. It's often referred to as nature's superglue. So what it'll do is, it'll start binding aggregate in that soil structure. So if you have light soils like sands, it starts to bind that together and give us areas where now we're starting to build our soil biology, our nutrients, and allow it to hold water. So it helps to build that organic matter also. The other thing it does is these red lines are what you call hypha. Hypha is like the human blood vessel in the soil. It transports high volumes of water and nutrients direct to the plant. Most important though is this fine network. When you look at root structures, the more surface area you have on a root structure, the more absorption you're going to have. So what this will do is allow that plant to get out to farther areas, absorb more nutrients. Specifically, what it does is on phosphorus. Phosphorus is relatively immobile in your soil. The plant has to go get it to bring it in. It does help with making less susceptibility to drought. And the way it does is these glomalin areas actually attract water. And when it comes in, mycorrhizal actually stores it internal in this vast network. When the plant calls for it, it'll deliver. I know for a fact, for example, on corn, it'll extend the life of corn 7 to 10 days longer with it than without it. So it gives you a little longer to hopefully catch a rain and recover. This again is this hypha, or lack of a better word, the channel that takes the nutrients in. The other thing I like about mycorrhizal, if you are careful when you dig it, it is visible. So you can actually dig it up, and that's what you see here in these kind of fuzzy areas and light colored areas. That's the propagation of mycorrhizal. Mycorrhizal right now in most farm journals, this is the one thing they're talking the most about, because we're starting to understand how important mycorrhizal is to the soil and realizing it's not there. So if we're doing bioaugmentation, what should we expect? We should be able to expect increased water holding capacity, improved soil biodiversity, most importantly is improved nutrient utilization. Get it back out of the soil. Get what's in that bank account out. Because remember, with your nutrients, there's some that are available to the plant, but so many of them, based on your soil chemistry, are tied up in the soil. And the only way they're going to get to that plant is through your soil biology. Some of the others is this increased organic matter, increased crop yield, but more importantly, it's a better way to do that asset management that we talked about in the very beginning. So soil is a living ecosystem, meaning it's constantly alive, never really stops, especially down here in Texas. you don't have deep frost lines. So it doesn't even really put much of an emphasis on stopping it. And what you look at is this diagram over here. The soil, the plants, and your soil biology are all interlinked. One link's broken will terribly damage that soil. On the microbial functions, it's kind of how we build these products. If we need nitrogen fixers and decomposers, we can even put bacteria in that their primary focus is root development. And it's developed via bacteria being able to produce some of these phytohormones or just hormones that help the roots develop. Things like your micronutrients that you really need, even in grasses, things like zinc, boron, sulfur. Those are the micronutrients, and we overlook those too much because many of those are the catalyst to what makes things go, like photosynthesis, sugar production, all of those. So whenever I'm looking at soil analysis, I usually look at those micronutrients to better understand what's going on in that soil. Terra One. Terra One is our product, and it comes in 3 different types of products. HYC is the crop product. HYG is a grass product. Now in Kansas, we consider wheat a grass. So we really, HYG is, it can be considered a crop or a grass, but we consider it a grass because wheat grows just like all your other grasses. The difference between these 2 products is this. With row crops, they need certain nutrients at a certain cycle in their growth. So maybe like on corn, for example, corn needs a lot of phosphorus early in its cycle, then nitrogen and some of the others. Grasses, on the other hand, are completely different. The one thing that grasses need is a consistent push of nitrogen. Nitrogen, the green color in your grass is because of the chlorophyll or chloroplasts in the grass. That's what gives it the green color. This here will help promote those, but more importantly, push nitrogen into those. And the interesting thing is you can measure chlorophyll in grasses and really get a real good understanding of how much nitrogen's being pushed into that plant. More and more, we're looking more at grasses and trying to understand the complexity of how we can push nitrogen as well as other nutrients. And then Terra One CO, that is the OMRI approved for organic farming. For anyone that's doing organic farming, they have to have something that's in OMRI. So when we look at this, remember what I said, crop yield could be anything from corn to grass to vegetables. When you look at it, this concept here doesn't change. Climate, Terra One's not going to impact climate. I wish I could make it rain or stop raining whenever I want, but I can't. Soil management. We don't come in and tell our producers how to manage their soil. They know how to do it far better than we do. But when you look at the soil attributes, the physical, chemical, and biological, we can impact this with Terra One. And that's the area you want us to impact. Why do I go through that? Let me tell you what Terra One is not. It's not a silver bullet. It's not going to take bad soil and make it great soil. It's going to improve the soil, but it's just not. And what it's not is foo-foo juice, magic dust, all of those acronyms that biologicals get. We've tried to really make a solution using natural occurring microbes along with sound soil science to blend the 2. So when we look at it, how do we know if Terra One's working? We already told you it's a microbial. You can't see it when you apply it. Well, some of the tools that we can do is field testing. Some of them that we do is chlorophyll conductivity. Soil conductivity will tell you one thing right away, how much nutrients you have in your soil. Soil conductivity is really measured in the soil solutions, and it's electrical activity, just like conductivity is in a wire, at a much, much smaller scale. but this is a measurement of the available nutrients to that plant. So if we say we're going to push more, for example, we should see higher conductivity from our product after it's applied, and that's what we indeed do. Some of the others we can look at: soil pH, soil respiration. Kind of soil respiration is a look at where the soil is from a biological standpoint. And then we like to do audits. An audit's just trying to understand what's going to happen at harvest. So when we start to look at it, here's a good example of healthy roots, unhealthy roots, if you will. What we're looking is the mass of roots, and the finer the better. And if you look at the two, these are on the same field. This is untreated and treated. You see that uninhibited root growth. You see lots of fine roots. If you're experiencing a drought, you can actually look at the directionality of the root. Because in a drought, many times these roots are going to turn and move laterally because they're searching for water. So this is a visual indication of what's going on. And the more we do, this is where digging in your soil really helps too. You can start to see really what's going on. One thing is, the simple way to look at roots is how difficult it is to knock off that soil when you dig it. If you dig up a piece of grass and you shake it, how's that soil fall off? If you've got poor quality roots, you'll find it'll fall off quickly. Same thing with poor quality soil. Because as you have more organic matter, it's suspended in the roots tighter. And it's a real quick visual way to look at that. And with that, I'll take any questions. No, it's all the same spray because it's different than a chemical. Chemical, the reason you can spray at different rates across the field is chemicals are based on concentration. So, and you can spray more or less, just like you were talking about, because you know of how it'll react. With bacteria, it has nothing to do with concentration. It has to do with the number of bacteria in that acre. Here's why it's so important. In order for this product to work, we know you have biologicals in your soil right now. That's Team A. We're getting ready to put Team B in. In order for Team B to do their job, they have to immediately go in and outcompete Team A. They have to outcompete them. Otherwise, you just get this struggling and you won't get the impact you want from a product. The reason I say it in that way is that's part of the problem with some of the biological products out on the market. They're too low in concentration.
I guess my question was, does the soil, type of soil make any difference?
No. I get the question too, is it going to perform better on my good soil, my bad soil? That term is relative to me when I say it. It's going to perform in both. It might show you a little better in poor soils because it doesn't have, the soil just isn't performing now. So any performance looks better. When you get to your better soils, it's not that it doesn't perform. It really does perform well. It's just that it's kind of like it has to go farther to show that response. Go to the sandy soils easy because in order to hold nutrients in sand, you got to keep them from flushing through the root zone. And one of the best way to do it is with mycorrhizal. That glue really works well and it'll build aggregate and let you hold them. In tighter soils, mycorrhizal also helps. You remember I talked about those red lines, those hyphae? They will penetrate tight soils and start to loosen it up. Now, that being said, it's probably going to see from an aggregate building in light soils, you're going to see that faster than tight compacted soils. Because tight compacted soils, now we've got a bigger challenge in those soils in many respects. Usually in your tighter compacted soils, you have a different chemistry too going on, so the chemistry comes into play on how well the nutrients release in the soil. Let me answer that in two ways so we're clear. On row crops, it's designed to be a one-time application because you have to get it in at germination of seed so you can push the nutrients. On grasses, it's a little different story. On grasses, it could be applied across a growing season 2 or 3 times, especially while you're rebuilding the soil. The key is, and again, you got to remember I'm the science guy, so I'm just telling you like it is. The key is, for me, is it has to make financial sense if you're going to apply it that many times. The reality is that you could apply it once and push it through a growing season, but you will have to, typically in damaged soils, we tell everyone you're going to have to apply it every year until we can get that buildup. And that buildup occurs, we don't have a timeline on it, to be honest, because that buildup in some soils might take 2 or 3 years, and others it might take 4 or 5. We just don't know. I can tell you better if I could look at your soil chemistry, your soil health. I can tell you more there, but generally speaking, that's where we're at. And we do have guys, to be honest with you, on some of the big pastures are applying it 2 or 3 times a year. Remember about humates, humic acids, something as simple as sugar, table sugar. Those are all biostimulants. Biostimulants and biological products like I'm talking about tonight get all lumped into the same category. Even to the point, if you would look at a label of a biostimulant and you would look at the label of a bacteriological product, they're probably going to make the same claims. The reason they do, it's not saying either one that the biostimulants are misleading by any means. A biostimulant is a chemical that you're going to throw in the ground and stimulate the soil biology. A biological means we're going to put the right bacteria in to get the outcome we're looking for. My challenge is if you have poor soil biology and you stimulate it, at the end of the day, you still have poor soil biology. You just have an excited one. And the other challenge with biostimulants, they're not long-lasting. Because they are a chemical, they're not long-lasting. So you might get a surge and then it falls back. That's the difference between them. Humates, humic acids, great source of carbon, but they also are, that's one of their limitations is they are a chemical treatment. In the world of chemistry versus biology, biologicals are slower to get an outcome, but they're longer lasting. A chemical is designed to do what it does. It's to go in, have almost immediate impact, and it's done. That's kind of the difference between the two. Terra One is compatible with all biostimulants. It's not going to hurt a thing. And like I said, we have a lot of growers now that are using sugar as a biostimulant. Great source of carbon.